Hi. If we really understand the causes of a successful project, we have a pretty good idea of the failure modes because we basically just look at what could prevent those key causes of success, what could prevent them from happening. So let's look some at the way our projects could fail. And we're using the tool failure modes and effects analysis. So in our little guidebook, I don't know if you got this or not, but I still highly recommend it if you're going to later on pitch yourself as a yellow belt, even though you'll have the certificate, but can you even remember the jargon and such? This is a good way to sort of remind yourself. Is this little gold QPC yellow belt memory jogger. So on page 89 of the jogger, it starts a discussion of failure modes and effects analysis. We assess risk to customers if a key process input fails, and we assess it in a way that we can rank the risk. We document the process, document process improvements, and it ranks processes or products by risk factor. So how can this product or process fail? What are the ways or the modes in which it can fail? What happens? What's the effect of those particular failure modes? What happens when those failures occur? And what are the causes? So you could have a particular failure mode that could show up more than once in your failure modes and effects analysis because it can be caused a number of different ways. So for every cause, we want to make sure we capture that. Identify potential causes of the effects and their probability of occurring, rate the likelihood of detecting the occurrence, and then how severe is that particular failure mode. If it were to happen. So we multiply the severity number times the occurrence probability times the detection probability to create a risk priority number. Larger number means more risk in some way or another. And then we identify ways to reduce or manage the risk. That's the right portion of the failure modes and effects analysis tool. We revise occurrence and detection numbers as control actions dictate. Usually if the failure is going to happen, it's still as severe. Now there are occasions where what you've done is not reduce the risk, not reduce the likelihood of occurrence or the likelihood of detection, but you actually have, in some way or another, made the severity less. That's not normally what you do, but it can happen. So that's sort of an exception to what we have. So the left side of the model looks like this, and then the right side looks like this. So on the left side, what is the function or process that we're talking about? How can it fail? One function could fail in a number of different ways. What are the potential effects of the failure and the severity? What are the potential causes? How likely are to occur? And what are the current process controls? In other words, how are we currently catching that failure? And then the multiplication of the severity times the occurrence times detection is a risk priority number. These are whole numbers. It can be a 1 to 10, it can be a 1 to 5, it can be a 1 to 100 number, usually 1 to 10 or less. And then on the right side, for each one of these, if there's some sort of risk, then how are we addressing the risk? But I would say that once you've filled out this part, you sort so that the highest risk priority numbers are at the top. Because we always want to do that in management. In communication management, you always want to make the most important issue the first thing you talk about. This is not a novel where you surprise people along the way. You don't want to surprise management. What are the actions? Who's responsible? And then what are the actions that you actually took? This may be exactly the same. You may not even want to fill this out unless you do something different than what you actually plan to do. And sometimes that happens. And then what's the revised risk priority number? If you haven't actually taken it, you're just proposing it, then on each of these cases, it's a proposed new number and a proposed new risk priority number. So outputs, ranked lists of products that contribute to risk, list of actions, person responsible, and then a ranked priority list. How can failures occur? Almost always they can occur in terms of quality, cost, and delivery. I can fail in such a way that the product just doesn't do what it's supposed to do. I can fail in such a way that it's a lot more expensive than perhaps is even acceptable. And I can fail particularly if our product is a service. I can fail because it's late. So this delivery is a time factor. I can fail in the service of it. I can fail in the supply process. There's a lot of different ways. Now, the next tool that we want to look at is, can we design a tool in a way that it won't fail, or if the failure is there, the severity won't be bad at all. And this is looking at the cartridge in a saw-stop saw. And the saw-stop cartridge and braking mechanism will cause the blade to stop in, like, I don't know, it's a couple millionths of a second, I think. And so instead of cutting someone's finger off or their hands off, you might get a painful little cut at the end of your finger rather than just slicing your hand off. So you've made the severity of the mistake incredibly less, not changing anything else about the process. You've just made that severity less. So it's a little bit different. You might not think this is completely mistake-proof, but mistake-proofing takes a number of different forms. The term mistake-proofing is, the Japanese term is poka-yoke. I prefer that you learn the English name, but part of the whole business of Six Sigma is that you learn the vocabulary that's likely to be used. And so there are a lot of people in Six Sigma that are going to talk about poka-yoke. Just know that it means mistake-proofing. It's not fool-proofing. A creative fool can get around all kinds of mistake-proofing devices. This is a mistake-proof. Then validate solutions with a pilot. And in this couple of slides, I'm referring to the book Sprint, Solve Big Problems and Test New Ideas in Just 5 Days by Jake Knapp. To me, this is a fantastic book. Knapp was sort of a team leader with Google Ventures. And sometimes you have books where people just have an idea, and then you have other books where somebody's had an idea, they've tested it and tested it and tested it, and that's really what you have here. So when we get into this idea of solutions and validate solutions, pilot and prototype, we're really talking about a form of project management, or at least a step in project management. So if your product is a website, app, or program, then you can prototype it through PowerPoint or Excel. If it's a report, your output is a report, brochure, memo, you can prototype it with PowerPoint or Word. If it's a service, this is really a little different. You can write a script and then use team actors to act out what the service would be like. What you're trying to do in all this is to do this in front of potential customers to get good feedback early, so you can really say, okay, the solution is right, the solution that we've chosen is good, or do I need to improve the solution? If it's a physical product or machine, you can modify an existing product. You can 3D print or prototype marketing materials with PowerPoint. Some guidelines from the same source from Knapp and Company. The picture here is like a studio false fronts. We don't have to build the whole thing. We just want to make it look real enough to where someone can suspend disbelief and get involved in the process and give us good feedback. You can prototype anything. Prototypes are disposables. You don't want to get too big or too small. You want to be Goldilocks, just right. And as much as possible, you want to make your prototype real. Manage it like a project. Charter, work breakdown structures, sprints, and if you're going to use sprints, I do really recommend this book. I read a lot of books, and most of them I'm very disappointed. This is a good book. And then finally, correct and reevaluate potential solutions. and then we're off to control.